Okay, so like I mentioned to you earlier, I'd like to get started, please, okay? So doing a new section today, 3.9, called Differentials. And then right next to it, I just put a little vague statement like used to do error analysis, okay? Pretty vague right now. Tomorrow, hopefully, it'll become a little clearer. So what I want to do is I want to actually set up the theory behind this, okay? Theory behind this. And again, this concept that we're doing in 3.9 is extremely useful in industry, okay? People out, I don't know if you've ever heard the term like back of the envelope calculations. Have you ever heard that? No? Has anybody watched Apollo 13?
Yeah.
You watched Apollo 13? Do you remember that they are doing some calculations on a napkin?
Yeah.
Okay? This is the kind of stuff they do on the napkin. Okay? It's kind of estimating and things like that, but extremely powerful, okay? And its origins are calculus, okay? So what I want you to do is I want you to follow the instructions that are laid out here. And this is stuff that we've done before, okay? So I'm just going to give you this stuff, pause my recording, and watch you guys sweat. Okay, you guys paying attention. So first of all, Jessica, tell me what's f prime of x, given that fx is this. Sorry? Cosine x. So you know that the line's going through the point 0, 1. Right? So what is x equal to? 0. So what's f prime of 0 equal to? Cosine of 0, which is 1. Yeah? So cosine 0, which is 1. Okay? So you've got a line whose slope is 1, goes to the point 0, 1. How do you write the equation of that line? Yeah, exactly. Can you rattle that equation, the formula for me? Fantastic. Good job, girls. Good job. Nice. Okay? So that's your fundamental point slope form. So what is y1 equal to? What's y1 equal to? 1. So you get y minus 1. What's m equal to? 1. What's x1 equal to? So what's the equation of the line? Y equals x plus 1. Okay? So what I'm asking you to do is I'm asking you to graph this equation. So put y1 equals 1 plus sine x. Put y2 equals x plus 1 in your graphing calculator. Yeah. Cosine of 0 is 1. The slope is cosine x, right? Isn't the tangent f prime x? Isn't f prime cosine x? Derivative of 1 plus sine x is cosine x. Okay? And if x is 0, because you can see it right there, that's your x value. So cosine of 0 is 1. That's where I get 1 from. Yeah, your windows are specified right here. Okay, your windows are specified right there. So can you please do that? And I'll do this on my calculator, okay? So, please make sure your calculator is in what mode? Yeah. No, you got to use your judgment to, yeah. What? What happened there? Well, I'm telling you that the mode should be radian and I have it in degree. Haha. You know you're being recorded here. The principal views this thing and hears some cuss words except from me, you're in trouble. Do you guys get a shape like this? Oh, you want to see what y1 and y2 are? Okay, hang on a minute. Have you got this stuff down? Have you got that line there? Okay, I'm waiting for Trina to tell me yes. It's right there. The Windows tool, right there. All right, so when you graph this, my claim to you is that in this small region here, in this little region here, you can't distinguish the straight line from 1 plus sine x. They look pretty much the same. So what this means is the line x plus 1 is an approximation to 1 plus sine x. You guys get me on that? Because in this small region here, you can't tell the difference, really. Okay, you really can't tell the difference. So 1 plus, or x plus 1 is an approximation to 1 plus sine x. Question? They're going to be very close. They won't be exact because, again, it's an approximation. Yeah. Okay. So then you come up with this conclusion here. Okay. Can you guys copy this? Okay. It's 1. What's f prime of c? What the? Can I use the f word while I'm being recording? What's f prime of x? What's f prime of x? Cosine of x. We just agreed that c is 0. So cosine of 0, 1. So this is a 1. You guys got that? That's a 0. That's a 1. That's a 1. You guys with me? Do you have everything on the right hand side of this equation? Can you go plug and chug on that and tell me what you get? What? You know what? I think I got to be careful here because I'm going to be cussing so loud in here. I'm going to get into a hell lot of trouble here. Seriously. Yeah, I am. Leo. There's no camera. I'm not telling you where the camera is. Are you kidding me?